All right, let's go. We'll start with some notes. What? What? What's your problem? You want cheese to go with that wine?
Yes. That's a good one. Sounds like something my mom would say.
What is that?
What?
You forgot us This guy, come on.
Mark, is that where you relate to accounting?
Wow.
No, I wasn't. It doesn't matter, it's accounting. It's tuna.
She doesn't care.
She doesn't care.
That's pretty rude. You're not gonna color that.
Why don't you shine some light this out?
Sorry. I forgot to say it, sorry.
You should probably tell me he did a great job.
Mark, since
Yeah,
you're going to
I
be
clapped.
busy taking notes, would you care if I went around and distributed donuts to people? Thank you. I'm distributing donuts. Sprinkles!
He's distributing donuts, and you're just saying class.
It's 4 minutes late. And I haven't
Okay, so just for clarification,
I mean,
remember we're
basically the same thing.
still in chapter 4. Your quests are graded. What I'm going to do is I put the quest grades, I counted those as 42 points. What I will do is after we finish with change of variable stuff, when you get back from, ladies first, when you get back from break, you'll take another quest on UDU stuff, and then I'll figure out how to take the quest that you've already taken and the quest that you'll do on UDU stuff, and then meld that all together into a test grade. So right now it's only 42 points. Eventually those two things will account for 100 points, as a chapter test should be. Okay, so what change of question? Yes. What change of variable allows us to do is to solve problems involving integrals for which we can't already solve. So for instance, if I asked you to find the integral, write this down by the way, solve the integral from 1 to 4 of the function square root of x dx. You can all do that, right? Beautiful. And I'll write that on the board in a second. Okay, so if I asked you to do this, the integral, what did I say, 1 to 4?
Yeah.
1 to 4 of the square root of x dx. You could all do that, right? Tell me how, Alex.
You take the integral of square root x, and you plug in 4, and that, and subtract, and you plug in 1, and then subtract 2.
Beautiful. What if I change that? What if I change it though? What if I do the integral from 1 to 4 of the square root of 8x minus 5 dx? Now that's a little uglier because all of a sudden we have a chain rule. And what do we know about chain rule?
No.
It doesn't work. So this will allow us to get around the chain rule and take the integral of nastier functions. How do we do it? It's called a change of variable. So we're going to introduce this idea of u du. The trick to solving these problems is picking the right u value. That doesn't make much sense now, but you'll see as I work through the example what that means. So I'm going to take my original function and I'm going to choose a variable, u is what we normally choose, and I'm going to have u represent something. I have a couple options. I could have u represent x. Okay, that would be dumb. I could have u represent 8x minus 5. That might not be so dumb. I could have u represent the square root of 8x minus 5. I have a couple different options. And what's going to happen as you work through UDU problems is you're going to make the wrong choice. Well, that's why you have an eraser. You erase it and go from there. The trick is going to be realizing when you've taken the wrong, you've made the wrong selection. So I'm going to do 8x minus 5. You will be doing a sidebar on each of these. That's why I have this over on the side here. Okay? So you'll see that that's the right choice because I kind of know what I'm doing. So I'm going to work through it first, and then I'll take you through a couple more examples once you have an idea of how this works. Okay, next things, I have to take the derivative of both sides. Derivative of u is du, or 1 du. Derivative of 8x minus 5, 8. But I took the derivative with respect to x, so I got an 8 dx. Now this could get confusing for some of you because it's been a while since you've taken derivatives. And I saw some people yesterday on the quest have trouble taking the derivative of something like x cubed. So we'll see what happens. Next step, solve for dx. We good so far? Now we do a whole bunch of substitution. I'm intentionally not putting the limits of integration in this problem. You'll see why in a second. Okay, so I know that 8x minus 5 is u, so I get the square root of u. What's dx equal to? 1/8 du. I don't like the 1/8, so I'm going to put it out in front because it's a constant. It doesn't matter. And I get that. And again, I intentionally did not put the limits of integration in there. You'll see why in a second.
Wait, so dx is actually like a variable? It's not just notation?
It's an indicator.
Okay.
Yeah, it's
So
telling
you
you,
can actually something.
yo, this is my variable, x.
Okay.
Right? So that's why when I took the derivative of u, I get 1.
Right.
But then you got to let people know u was my variable.
Right,
I
okay.
took the derivative of 8x minus 5, and you got to let people know that x was my variable.
Okay.
Okay, now we do this. What's the integral of u to the 1/2 power? Now, no plus c here. Even though there's no limits of integration, don't be slapping a plus c in there. We'll get to that later. Let's clean this up with a couple equal signs in here just to keep things all neat. Okay, we good so far? Good. Now, plug back in what u is equal to. Well, you know what? I'm pretty smart. I can probably do this ahead of time. That would be 1/12. 8x minus 5 to the 3/2. Now I have it in terms of x. So therefore, I still need to evaluate from 4 to 1. Now, why didn't I put limits of integration in that other step? Because u has different limits of integration. There's two ways you can solve these u du problems. One method would be to change your limits of integration. The other one is to use this method. I'll show you the other one in a second. Okay, plug in 4. And it's going to get ugly. 32 minus 5 is 27. What's 27 to 3/2? Square root of 27 is not a pretty answer, so we're going to get some ugly number.
142.96.
Wow. Yikes. We could. Let's do 4 times 27 to the 1.5 power divided by 12 is, take your answer and divide by 12.
11.691.
Minus 8 minus 1 is 3. 3 to the 1.5 power divided by 12.
.541.
And then subtract those.
It's 11.5. 11.15.
1.5.
Just that's
That's horrible. Good. All right, let's go through another example. The integral of 8x to the 5th minus, I could read this, 7, all raised to the 9th power, times x to the 4th dx. Okay, you got a couple options. One option would be to multiply it out. Anybody up for that one? I didn't think so. But that is a viable, oh, I need limits of integration here. No, let's not do limits of integration. Let's do it as an indefinite integral, just for giggles. Okay, we'll leave it as that. So I'm going to do a u to u. The question is, Madden, what do you want to use for u?
8x to the 5th minus 7. Would you, is that it? Or would you use it?
You're driving the bus. You want to try that?
Yeah.
How's everybody else feel about that?
I think the question is how do you feel?
Well, it doesn't matter how I feel.
How are you supposed to decide?
You don't.
Don't use guess.
Well, you'll learn through trial and error some tricks, and I'll show you some tricks later, recognizing what u is. Without actually doing the work, and we'll come back to you in a second, why do you think that might be a good choice? Raymond, are you raising your hand, or are you just waving your hands in the air like you just don't care?
Most of it simplifies most of it, so it's then just u to the 9th power.
That's a great answer. Let's try and see what happens. Worst that happens is you're wrong, and then we just point and laugh.
That's fine.
You're okay with that, right?
Totally.
Good. What's the derivative of u? du. What's the derivative of 8x to the 5th minus 7? Don't forget the dx. That's important. Now solve for dx. So dx is equal to 1 over 40x to the 4th du. Does that make me happy? Did you choose wisely?
Probably not.
I can flashbacks to
Yeah.
Holy Grail, like Indiana Jones.
That's why, yeah, good, nice pickup, yeah. Yeah, he chose poorly.
Because
And
you're
then his face melted.
getting the,
That probably won't happen here.
so the D is the
It-
derivative of u, since there's a
There's a first,
There's a definite
there's a first time for
possibility.
everything. Yeah. Oh, good, was that a Dumb and Dumber reference?
The derivative
Yes.
of
Yes.
So there is a chance. Am I happy about that answer so far? What's going to happen when I do a substitution?
It's gonna be ugly.
No,
No,
the
really?
exact opposite.
It's gonna work.
Attaboy. We're going to get some canceling here.
Wait, I did it
Okay,
right.
so this becomes you, me.
Good one. We.
I'm going to do the next step just because we're starting, but eventually you won't have to do this. I have an x to the 4th with nothing to do with it, so I'm going to write that down there. And then I know what dx is because I solved for it over here. 1 over 40 x to the 4th du.
Wait.
Yeah.
Okay.
So I turn around and she's got a reindeer on her head. You haven't had that on the whole period, have you? You just put that on?
Yeah.
I understand. No problem. So that's simple. Move the 1/40th out in front. 1/40th times the integral u to the 9th du. Is that good? Yes. And what's going to indicate that it's good? If you get done with your substitution and you've got u's and x's, you screwed something up. Which means you probably chose the wrong u. Or you did a derivative wrong. Okay, what's the integral of u to the 9th, Mary?
1/8 u to the 8th.
1/10 u to the 10th. And in this case, we got to do a plus c because we're doing an indefinite interval. Which we can clean that up to be 1/400th.
Oh, great.
Oh, not u. I lied. No, wrong button. 8x to the 5th minus 7 raised to the 10th power plus c. All done. Pregunta.
Are we allowed to keep it like that?
Yeah. What else would you do with it? Multiply it out.
That would be fun.
Okay, let's try another one. Let's do this one wrong.
Oh, I thought I did that.
Never thought I'd do that. Well, you just did. First time there.
I need to type my notes in a bigger font.
That's true.
Haley, you're pretty smart. What would you choose for you here?
X to the 5th plus 3x squared plus 5.
Excellent. Now, let's take a different approach.
Okay.
Haley, you're pretty dumb.
Okay.
What would you choose for you?
5x to the 4th plus 6x.
Fine.
Over.
So we'll pretend for a second that Haley has no idea what's going on. And I want to do this wrong so that you can see what it looks like when you choose the wrong u. Okay, don't be dumb anymore, Haley.
Okay.
What's a derivative of u?
Do you?
Good. And the derivative of 5x to the 4th plus 6x?
20x to the 3rd plus 6 plus dx.
Good. Solve for dx. Okay. And I'm just going to keep going right along here. So I know that's u up on top. I'm good to go. I got nothing to substitute there, so I get x to the 5th plus 3x squared plus 5 squared. And then I know that dx is equal to this mess, so I get 1 over 20x cubed plus 6 du. And now you realize why that was a bad choice. Right? How do I know it's a bad choice? I canceled everything I can cancel. I've got u's and x's, so therefore she made a dumb choice. Okay, thank you.
You're welcome.
Good job. Her first response was correct, in that you choose this business to be you. So let me get rid of all this mistake.
Oh, really? No, you're fine.
Yes?
Answer my question. So, like, if you do have a fraction, do you want to choose the denominator so that the top and the bottom?
I hesitate to answer like always do this and always
Yeah.
do that. What you should notice is that the numerator is a 4th degree power.
Yeah.
The denominator, the inside part of the denominator is a 5th degree. So what happens when you take the derivative of a 5th degree? You get a 4th, which should cancel.
Yeah.
So a helpful rule of thumb is you usually want to choose the higher powered chunk of stuff.
Yeah.
So we did x to the 5th plus 3x squared plus 5. So du is equal to 5x to the 4th plus 6x dx. So dx is equal to 1 over that whole mess, 5x to the 4th plus 6x du. Now you can see much happier, right? This time I'm not going to do that extra step. I'm just going to do my substitution right away. This guy up here would cancel with this guy down there. That goes away. The bottom becomes 1 over u squared. The dx and the du sub out, and I'm left with that. which makes me happy because that's a nice easy integral. U to the negative 2, do the antiderivative, sub back in for u, don't forget your plus c, done. Okay, not so bad. Life wouldn't be complete without some trig. You want an easy trig or a difficult trig?
Easy.
Easy, all right. Cowards.
So hard now that everything else is easy later on.
This is so easy, I'm not even going to take it all the way through. What would you choose for you? Nope. Because then when you take the derivative, you'll get cosine stuff and you'll have a mess then. 12x? Is that a good choice, Connor? After I've done all that stuff?
Yeah.
Why? What's this become?
The sine 12x, what does it become?
Yeah, when I do my substitution.
Oh, the 12's canceled. No.
No. Michael?
Does it become sine of u du?
You missed something.
112.
Yeah, gotta keep that 1/12 guy in there. Take the antiderivative of sine, plug it back in. Life is good. Okay. Any problems with that? Okay, two quick things that might be helpful, and then we'll be done. What can you tell? Let's talk about odd and even functions. If I give you a function, how do you determine if it's even or odd? We'll talk in simplistic terms, let's say a polynomial function. How do you know if a polynomial function is even or odd? Power of the exponent, keep going. Are you talking just the degree or all the exponents? All the exponents. Yeah. If all the exponents are odd, then it's an odd function. If all the exponents are even, it's an even function. If you have a mix of even and odd, then it's neither. Now, be aware of this. Is that even or odd? That's odd, because it's raised to the first power. Is that even or odd? It's even, because it's x to the 0 power. Okay. So an even function would be something like 3x to the 4th plus 2x minus 4. An odd function would be something like x cubed plus x. What happens when you graph an even function? What's special about an even function when you graph it?
How would this be an even function? Because
Oh, it wasn't. I think I said it and didn't write it. There you go. Thank you. Good catch. Yeah,
The two ends in going in the same direction.
keep going. Anything else?
Positive. Is it positive?
This is
Or
It-
on
Doesn't necessarily have to be.
the graphs are symmetrical.
About?
The y.
Good. This has y-axis symmetry. Okay, so if you look at something like a basic parabola, x squared, it's y-axis symmetric. Same thing on the left as on the right. This leads us to the theorem, and the theorem says the following. If I'm looking for the integral of an even function from negative a to a, that would be the same thing as the integral from 0 to a times 2. Okay, does that make sense? If it's symmetrical about the y-axis, and I want to find the value from negative a to a, if I just find one of them and double it, I'll get the same answer. Okay. It's not an earth-shatteringly important theorem, it's just something that will make your life a little bit easier. Especially when you have to plug, when you're doing a definite integral, it's a lot easier to plug in 0 than it is to plug in negative 4. All right, what about an odd function? What kind of symmetry does an odd function have? Sorry? Kind of. What do you mean by oblique?
Like on an angle.
Well, there's 3 types of symmetry. X-axis, y-axis, origin. Origin symmetry. Remember, the trick to determine if something has origin symmetry is to flip it over. If it looks the same right side up as upside down, then it would be origin symmetric. Nice, easy origin symmetric function would be x cubed. What if I go from negative a to a? So what is the integral from negative a to a of g of x if g of x is odd?
Zero.
Ooh. Why, Mr. Smarty Pants?
Because negative a to 0, it's negative whatever, and from 0 to a, it's positive, the same thing, so it cancels out.
Right. These two areas are the same, but since one is negative, they would cancel each other out. The odd function thing is a lot more time-saving than the even thing. I mean, just boom, done. 2 things you need to check. Is it even or odd? And are you going from the same value? You can't just realize that it's an odd function and say, okay, I'm going from negative 2 to positive 7, it's equal to 0. It's got to be symmetric. You got to have the same value on both sides. Okay? So 2 helpful things. The main focus, however, is going to be U du. So tonight's stuff, I think, I'm 99% sure that most of tonight's homework is all indefinite integrals, where you sub back in at the end, but you don't have to evaluate. Tomorrow, or when we come back from break, we'll start looking at problems that are indefinite integrals. They're not that more difficult.
Do we have homework over break?
No.
Okay.
So you got homework, well, kind of. I mean, I have an assignment tomorrow.
Okay.
But if you get it done, I will have a winter extra credit for you that I'll talk about tomorrow.
Okay.
And how that whole thing's going to work. Okay. Questions, concerns? Anything for the good of the cause? Outstanding. I have no idea what day this is.
Okay.
62?
It'll be on the calendar, right?
It's on the calendar, yeah, I just don't know what day. It's the first day of 4-4.
Our last day was 60.
Okay.
Wasn't 65 the
There's a whole bunch more donuts. There's half a box here, and Mark's got a whole nother box, so come on up and help yourself.
I thought you were passing them out.
I just hear the shark feed.
But he only gave us